Miss Lee's Chemistry Academy, Lab 8, Molar Mass of a Gas. Investigation. In this lab, a student is assigned the task to determine the molar mass of butane gas contained in a lighter. Butane is a nonpolar substance that is insoluble in water. Because of this, the butane gas can be collected by water displacement by releasing it from the lighter. In this lab, you will need to collect data on the mass, volume, temperature, and pressure. Once you have this data, you can calculate the molar mass of the butane gas by using the formula molar mass equals density times constant R times temperature, all divided by pressure. Procedure. The first step in this lab is to mass the lighter you'll be using the whole experiment on the electronic balance. Then, set up the apparatus that will collect the butane gas by filling a 250 milliliter graduated cylinder with water and turning it upside down in a water bath as illustrated in the next photo. Then, take the lighter and place it in the mouth of the cylinder and press on it to release the gas into the cylinder. Make sure that all of the gas is being collected in the cylinder and none of it is being released outside of the cylinder. When a sufficient volume of gas is collected, equalize the pressure inside and outside of the cylinder. Record the volume, temperature of water, and air pressure. Lastly, dry the lighter thoroughly and mass it again. Apparatus. In the photo on the left is the lighter that you will use in the investigation, and in the photo on the right shows the apparatus used in the lab to collect the gas from the lighter. Butane gas collection by water displacement. In this photo, the lighter is in the mouth of the graduated cylinder and is releasing the butane gas, which is being collected in the bottom of the cylinder. Data. To calculate the molar mass of the butane gas, there is a few data points that must be recognized. The mass of the lighter before gas was released, mass after gas is released, air pressure, water temperature, water vapor pressure, and lastly, the volume of gas collected. Calculations. In the first calculation, the mass of the gas is released is calculated by taking the initial mass minus the final mass. To find the pressure of the gas, you have to account for the water vapor pressure, so you need to take the air pressure minus the water vapor pressure to find the pressure used in the calculations. Then, to find molar mass, you will take all of the data and plug them into the equation molar mass equals density times constant R, temperature, divided by pressure. Lastly, to find the percent error, you take the calculated percentage minus the accepted percentage, or the actual, and divide it by the calculated percentage and multiply it by 100, which will give you the percent error. Error analysis. Some possible points of error include 1. If the butane lighter was not thoroughly dried after being taken out of the water bath, it would make it appear to weigh more. 2. If the mass of gas calculated is smaller than the actual, then the resulting molar mass would be smaller. 3. A major source of error could occur if not all of the butane gas released has gone into the cylinder to displace the water. The volume of gas collected would be less and the calculated molar mass would have been greater. Conclusion. The molar mass of butane determined by water displacement method is calculated as 50.4 grams per mole, with a 13.3% error.